Bismillahirrahmanirrahim. Assalamualaikum warahmatullah. This video will be part 6 video of my SolidWorks mini vacuum cleaner project. In my previous video, I have already shown you how I have done detailing of this rear and front casing, where I have shown you how I have done the supporting ribs to hold the batteries, the rechargeable battery, and also the supporting the slot to hold this PCB. Alright, actually I need to mention that I have made some few adjustment here, correction here. In my previous video, actually the slot here is little bit longer, and we have kind like interference overlap with this USB port. So I have already made some few adjustments, make it shorter so we don't have any interference, right? And also about the position of the battery, I have do some few adjustment. I make this battery little bit lower, so it means that I have some more space here, because later I show you how I will make a cut through holes for the wiring to make way for the wiring. Alright, so it means the position of the rechargeable battery I make it lower. Also, in my previous video, I forgot to add these features. If you look, if I'm not mistaken, in my part 3 video, where I've shown you how I've done this pin for this rear casing, and also the other 4 pins for the front casing. I forgot to add those features at this position. So it means that I add this pin at the rear casing, also pin at the front casing. So I will show you the continuation in this video for final detailing of this rear and front casing, where I will show you how I will do the fastening features. Since we have, as you can see, if I on the this front casing, we have fastening features. If I go to the section view, since we have this pin on the front casing and this bigger pin on the rear casing, I will show you how I will insert a screw, where the screw we do the fastening this front and rear casing. So I will show you how I will create cut through holes here, and how I will do the inner thread for this both pin here at the front and rear casing. Alright, so I will show you how I will do this in SolidWorks. Okay, to do the fastening features in SolidWorks, so I will not do in assembly mode, I will do in part modeling mode. So it means I open this main body file in part modeling mode. Alright, now I'm back in part modeling mode, where I have the front and rear casing. Alright, actually to tell you, I've already made a part modeling. Actually this screw, the screw M1.5, actually is an old file that I've done for my previous project for portable mist spray fan. The same screw size, which is a small screw M1.5. So I will insert that part in this part modeling mode. Right, so what I will do, I will here in part modeling mode, we can also insert part here. Under the menu we have insert, I will insert part. So I will browse for the screw here, the screw M1.5. so I will put the screw somewhere at this position. Alright, now I put the screw into position. Now I will do I will clone this screw into 4 copies. Total is 5, because we have 4 pins at the top and 1 pin, 4 pair of pins at the top and 1 pair of pins at the bottom. So before I do that, I need to create a cut through holes here. Since we need to fasten the screw at this position, it means that I have to do 4 cut through holes here, and also 1 at the bottom. Alright, in order for me to do that, I will go for plane, and I will select one of this flat plane can do. I'm not going to this direction, I go for flip. This is 25 from here. I think this plane is good enough for me to create. Let me put it much further, go for 35. Okay, for about this distance is 35. So this plane, I will do a sketch at this plane, and hold on, okay, hold on, and I want it to be turning to back directions. So this is a back view from the rear casing, and I need to create the holes. First I go for shaded mode, the style mode, then I will make a cut through holes. Okay, this, the bigger circle here is the outline of the bigger pin on the rear casing. The cut through hole is about the same size as this one, so this one will be, I will select the smaller circle here, and also select this one. I will select this one as well, and also at the bottom one. Then I will convert to entities. So I have a trace outline, of those circles, and now I will do extruded cut. Alright, before I do extruded cut, let me exit first. I will isolate first the rear casing. I don't want to disturb the front casing. And now I will edit this one, and now I will do extruded cut, features, extruded cut, and I go for this direction, and I must make sure that it's about, if I put on 25, let me check, I go for, let me go for 30. Okay, let me try for 30. So I made an extruded cut, and I will go for section view. Okay, let me go for section view. Then we have a extruded cut. Alright, for this at this position, and same goes for the other pin. As you can see, if I drag, so we have a cutout up until this position. Right, same goes for the bottom pin. Right, if I drag even further for the front pin, yeah, everything is good. Right, we have a cutout at this level. Alright, so I have done the cutout for the rear casing, and I on exit isolate, then I save my file. Alright, then what I will do, I will do mate setting. First I must duplicate this into 4 copies. Okay, in order for me to make this into 4 copies, I simply go to, hold on, I go for insert, hold on, I go for insert, pictures, move copy. For to do, I will not do the settings here, so I will go for the setting, translate, rotate, and make sure copy is checked. And now I select this original screw, then I make the copy is 4, so it means the total screw that I will do, I have is 5 screws. Right. Alright, since I have 5 screw already at the same position, let me just move it manually. Insert features, move copy. But now I uncheck the copy. I can select the clone here to somewhere at this position, and I have to do it one by one, and do again features, move copy. Make sure this copy is unchecked, because I simply want to move it. I don't want to clone to make a copy version. Click again and insert features, move copy, select this one, and this one I put lower like this. Click OK, insert, do again. This one I put at this position. Right, so much easy for me to do the mate setting, since I need to put each screw into this hole. Alright, the first mate setting will be, so I will do again insert features, move copy, then I will do not this setting, under constraint setting. Okay, now bodies to move will be this screw. Here the setting is similar like in assembly mode, the mate setting. So this screw, I have a cylindrical surface here, so I select the cylindrical surface, will mesh with this cylindrical surface, so automatically it goes to concentric. But as you can see here, the screw turning to this direction, so under the mate alignment here, by default is on the right one, so I click the left one. So if flip to this direction, I must click add, so it means it reads the first setting. right? My second setting will be I select this flat surface, because we have a dome head of the screw, but at here a flat surface. That flat surface already selected, and it must mesh with this flat surface, so the screw is in position. I click add, then I click OK. Now my first screw is in position. Alright, okay, my second screw I do repeat the same. Insert, features, move copy. Here bodies to move is this one. Mate setting, I select this cylindrical surface and it mesh with this one, but it turns to this direction. I go mate alignment, I flip to this direction, I click add, and now my second setting, this flat surface must touch this surface. Then I click add and I click OK. Alright, I will pause this video until I resume to the position where I have put the rest of these 3 screws into all these 3 holes. Alright, so I pause this video. Okay, now I have done putting all the 5 screws into position. Okay, let me show you the section view. Okay, let me click OK. Okay, as you can see here, the screw is in position, all the 5 screws. So what I will do, I will create actually this screw is not meant to be in this part modeling file. The idea of me putting the screw into position is for me to create the inner thread of this pin or on this rear casing, and also this pin on the front casing to create the inner thread. So I will do subtract, combine, subtract to do the inner thread for this pair of pin. Right. Okay, in order for me to do subtract, but each of the screw I need to clone it. I want to be subtract for this pin, and the other clone version of the screw to be subtracted from the pin of the front casing. So it means both of this pin we have the inner thread. Okay, let me show you. Before I do subtract, I need to clone. It's kind of like tedious, but this way that I think that we could do the inner threads. So it means that I will use translate, rotate. Bodies to copy is this one. I cannot select everything because the list is only one by one. Yeah, I can do that. Sorry, my mistake. I can do that, and I can select this one. I can select this one. I can select this screw. Then hold on, make sure delete it. Make sure I select the proper screw. Okay, this screw is selected. I select, yeah, actually this is the screw name, and this one as well. Okay, so make sure copy, and the number is 1. I mean all the 5 screw have a clone version, a copied version. So I click OK, and I simply click OK. Okay, hold on. As you can see under the solid bodies, we have it means that we have a total of 10 screw. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right, so each screw here we have clone version. In order for me to do this inner thread for the pin on the rear casing, since I have duplicated version of all this screw, it means this one we have the clone version here. So what I will do, I will select on the list here. If you look on the list here, so I will select the rear casing. So this is a rear casing. Sorry, this is not rear casing, this is the rear casing. I will select all the 5 screw. I select the rear casing, hold on my control key, all the original 5 screw, 1, 2, 3, 4, 5. That will be the original one. Okay, let me do it again just to check. Maybe I want to make sure it highlight this the right component. So the rear casing, and I will select this screw, not this one, screw at the back there, and this one, and also this one. So here I will do isolate. Okay, I still don't have one here, so it means, yeah, here this one I show it, right? I show it, so it means I have 5 screws there. So what I will do, subtract. Okay, under insert we have features, then I use combine, then I use subtract. So the main body will be this rear casing. Bodies to subtract, carefully select the 5 screw here. This one, carefully select this one, and this one. So it's already in the list, then I click OK. Okay, as you can see now, okay, I forgot about this. This one, let me edit back this, combine, edit back. I have this one, 2, 3, 4, 5. Okay, actually it's done already, because I think I have a clone version here. Okay, let me exit isolate, and hold on. I isolate only the rear casing. Just need to show you. For this pin of this rear casing, we have the inner thread. Yes, all the pin of this rear casing, we have the cut out the inner thread, right? And same goes here. We have the inner thread. Okay, exit isolate, then I will repeat the same procedure for the front casing. So it means that this front casing, I select the front casing and the 5 screw one. Okay, I select the front casing, hold on my control key, the 5 screw, make sure it's highlighted just to make sure. 2, 3, 4, and okay, 1, 2, 3, and this one. All right, so this one will be the screw, so I isolate it. Alright, now for this front casing, I will do insert, features, combine, subtract. Main body will be the front casing. Bodies to subtract, I'm using subtract. Bodies to subtract is this 5 screw, this 5 screw on. Then I click OK. Now as you can see, the front casing, we have the inner thread. So that's how I do things in SolidWorks, to create the inner thread and for the rear casing, and also the inner thread for the front casing. I exit isolate, and now as you can see, we have only 2 solid bodies, the rear casing and with the inner thread for the 4 pins of that rear casing, and also the front casing with inner thread for that 4 pins on the front casing. That's how I do things to make these features, right? Okay, the next thing to do, if you look at this main body, at the end here is actually will be attached to the cylindrical container. Let me show you the photo. So this is the cylindrical container, will be attached. Actually it goes to this direction, right? Will be attached at the end here. If you look at the cylindrical container, is a hollow things. Inside there we have the feature kind like this shape, L shape, is a slot, is a cutout. But as you can see here, at the end here of this main body, we have a key. The key is a L shape. Let me show you closer picture. So this is the end of the main body, so we have a key of L shape here, right? So this is kind of fastening features that you can find in most of plastic components on the market. And okay, the way to create this key, let me undo this thing. Typically I can do this way, but this one is not accurate. I make a plane above, I create the L shape, then I will do boss extrude from the surface and with thickness of 1. So this is not the correct way to do it. It's not accurate. The accurate way to do this is not using boss extrude. I will use wrap command. Wrap command means that at this center plane, as you can see, so since when you look from the side, this is actually a circle, cylindrical surface is circle. I need to know the diameter of the cylindrical surface. So it means at that center, at the middle position there, I will create a wrapping rectangle. Hold on, my sketch, wrapping rectangle. The width of that rectangle is about the height of the cylinder. Right, so this wrapping rectangle, the rectangle will be wrapped around the cylindrical surface. So I need to know what is the diameter of the cylinder, and it means that this rectangle, the length of this rectangle is the circumference of the cylinder. So I need to create this rectangle, and the width is actually the height of the cylinder. So once I've done, let me undo, let me erase all this thing. So it means that let me show you again this view. So it means I will do the wrapping rectangle at the middle there, at this plane. Sorry about my sketch. So the length will be the circumference of the cylinder, and at this wrapping rectangle I will create a L shape. The exact dimension of that L shape, it means that L shape will be wrapped around this cylinder. So this is the most accurate way to do the key. Okay, let me show you how I will do this in SolidWorks. Alright, now I have this thing. I need to know here, SolidWorks, under evaluate tab, I can measure what is the diameter of this cylinder. It's stated that the radius is 25, so it means the diameter is 50. So in order for me to create the, by using wrap command, I have to create the L shape. If you look at this photo, the L shape will be like this. Okay, on this side it means that I will create at this side, not at the top side, at this quadrant I will create the L shape to create the key. Alright, so it means that since I cannot do this at this both end, front and rear casing, since I have splitted this main body into front and rear casing. So it means I need to do a clone version, a cylinder about this size, so that cylinder is temporarily done by for me to do wrap command. Later I will show you then how I will attach it to this front casing and also rear casing. Alright, just watch how I will do it. Alright, so it means that I will create a cylinder about the same size. So here I have a plane here, so I create a sketch. So I will go for this one, and or maybe I can draw a circle at this center point and go snap at that point. So I have a trace outline by this is actually diameter 50. So then I will extrude. Okay, I will extrude. Hold on, I will use, by default is blind, so I will go extrude up to surface. So I will select to the surface. So I have this temporary cylinder, but this is important. I must make sure that this is not merged. I uncheck the merge result because I want to make it as a separate body. So I click OK, then I have this cylinder. As you can see, I have this cylinder, boss extrude 29, then I will isolate it. So this is a cylinder that I will do wrap command. So here if you look at the right plane, the front plane is actually laying in the middle. So I will click at the right plane and make a sketch. Now I'm in this viewing direction. So what I will do, I will create a center line from this middle point to this middle point, and now I will do the wrapping rectangle. I use the center point rectangle, then I will go like this, then this one and this edge I will go for make it collinear. Okay, about the length of this rectangle, since the diameter is 50, alright, since the diameter is 50, so it means the length will be the circumference of that cylinder, so it means 2 pi radius, so it means 2 pi 25. So I will give a dimension. Actually the dimension that is away, but I cannot recall it. You can put a symbol pi, 2 pi times 25. I just simply show you how to do it by using, by using calculator. So it means the circumference will be 2 pi radius, 2 times pi times radius is 25. So the value is this value. So I will copy, make sure I select all, copy. So this will be the value of the circumference. So I will put dimension here. I will click, so the value I will paste it. So that would be, so this the circumference of the cylinder of diameter 15. And alright, about this rectangle need to be changed to I select all the edges of the rectangle, and this one I change it to as for construction. So it means it become as a construction geometry. The only thing that I have to make a solid line is the shape of the key. As you can see from this photo, let me undo the sketch here. So the shape is like this. It's a L shape. Actually I already measure it. This one is about 10, this is 10, and the thickness of the L shape is about around 3 millimeter. Okay, this is 10 millimeter. So what I will do, I will create a L shape as shown in this photo. I will create L shape. Actually the L shape is as I mentioned before is 10. Actually it's not 10, it's 13. I do a correction. So this 13, the thickness here is actually is 2. Alright, the thickness is 2. Alright, so it means here in SolidWorks here I will create, okay, I simply create a line first because I need to position this L shape release in the middle here from the center line. So I simply create a straight line at the vertical. Then I will give a dimension of 13. I give dimension of 13. Alright, then I will bring my mouse here and right click at it. I go for midpoint, so it's already highlighted the middle point, and hold down my control key and select this point. Then I go for coincident, so it means this line will be balanced in the middle, right? Okay, now I will create the L shape, so another line will be touched at the end. Now I have the L outline, and then I will do offset. So as mentioned is 2. Then I will select this line, reverse direction, and make sure that selection is on. That's why I can trace all the outline there, and also the cap ends is line. So I have this outline for me to create the red comment. So I exit the sketch. Okay, I need to exit the sketch. Here under the insert features we have wrap. Okay, wrap command. So first I need to select the sketch, so I select any line here, and now this is a setting for wrap. And as you can see, the first option is for emboss. Emboss will mean it will create a key. Deboss will be a cutout to create the slot. Alright, so the second one I go for wrap here, and the sketch is already selected, and this is the face, so I will select the cylindrical surface of the cylinder. Now we have a preview here. Here is the thickness of our wrap, because I'm doing emboss, so I want it to be 1 millimeter height. So if I click OK, now I have the key. Alright, so this will be the key as shown in this photo. Okay, okay, what about on the other side? Since we have two keys on the other side. Actually it's not shown here. One is here, the other side will be there. So on the other side I cannot do mirror because it's the L shape orientation also will be at this quadrant. I cannot do mirror because it is a mirror representation, so it's not the L shape when looking from this direction. So I need to do circular pattern. Alright, we have circular pattern, so the direction can be the circular edge, and the features to pattern I can use the list here. The last one that I've done is wrap. Okay, here be careful about if I simply click OK, so what will happen? I need to show you. So it become like this, so this is not correct. And let me edit back the circular pattern. Then I will go for geometry pattern, and here I will go, instead of all body, I go for selected body, and sorry, I will go for all bodies. And if I click OK, hold on, as you can see now I have this key on the other side. Alright, okay, this will be the key, but actually this cylinder is not meant. If I exit, actually this cylinder is overlap with the this thing, the front and rear casing. Okay, let me isolate this cylinder first. Okay, the features that I need is only these two keys here, so it means this cylinder I will make a cutout, right? So it means that I can go to this this plane, then I will create a circle. Hold on, I will create a, it's not okay, it's not reading. I will create a circle from this point up until it touch this point, so I have a circle there. So this one I will do features extruded cut, and I can go through all. And now, okay, I just simply click OK, this one, and now I have only the two keys. Alright, so these are two keys. If I exit, isolate, hold on, so I have, if you look on the list, we have the back is cut extrude 16, and this one is the front key. So what I will do, this body, this, hold on, this one and the rear casing, I will isolate it. Okay, I will isolate it. Then this one I will join it by using insert features, combine. I will add the front casing and this key, so add, and it merge as one body. I have the key there. And about the rear casing, I will select this key, and the rear casing I isolate it, and then I will merge it, combine, use add, this one and this one. And now if I exit isolate, now both the rear casing and the front casing, we have this key. Alright, another thing that I found out, that if you look at this key, actually the key is not just like this. If you look at this photo, if you look closer at this photo, actually we have kind of like a cutout here, like a V-shaped cutout. If I zoom in closer, we have a kind of a cutout, a V shape. So the idea of this, since this is a cutout of V shape, and actually it will be fitted into this container. Let me show you again this container. If I zoom in, the container, we have the slot, the cutout. We have the container, we have kind of like a V key. So it means here we have a V groove. This one we have a V key. It means that when this one is fitted, and when we turning this container, it kind of like it will be snap fit, and it kind of like lock the position. This another features that it could lock the position of the container tightly fitted into this end of this main body here. Alright, so I need to do this. It means that, let me isolate this one, the front casing here, and here this plane I will create a sketch. It means that I will do a center line from the center point, hold on, it touch at this quadrant. Actually this is quadrant, sorry, actually this is coincident with this circular edge, because of the display resolution. As you see, this one is coincident because of the display resolution of my screen, right? So I will create another center line from the center point from here. So I will give a angular dimension. This one I will go for, maybe I can go for 8. I can go for 8. And now I will trace the circular edge and convert entities. Then I will create this line to make a V cutout, right? So, and this line, actually this is touching the circular edge, and I will go for this one is equal, and I need to give the circular dimension, I need to get the angular dimension. So this one I can go for I can go for maybe 50. Hold on. Okay, 50 is the cutout. Okay, let me go for 60, and then I will give since we have blue color is underdefined, so I need to give the from this point to the center, I give the radius value of if I go deeper, I go for 25. Not deeper, I don't want to meet I miss that, I don't want it to be too much at the side, so I go for 25. And now I can do trim, right? I can do trim, so I have the outline for me to create the V groove, right? So features, I will do extruded cut, and I'm using up to surface and stop at this face. Then I click OK. Then I have this thing, all right? Okay, so I will do the same at the back casing there. So I will pause this video, I will pause this video, and I will resume back to the position where I will do the same for the back casing. Okay, now I have done the V groove, okay, the V cutout for both of this front casing and also this at the back casing here, all right? Okay, I think I've done complete detailing of this front and rear casing. Inshallah, in the next video I will do another part modeling, which is the cylindrical container here. So, we have some features here, and also we have a cutout of this. Since I'm doing wrap command for emboss here, so here I will do this L shape to do the same wrap command, but this one is deboss, will be a cutout. Right, okay, inshallah I will see you in the next video. Thanks for watching this video, but before that, please do appreciate my effort to do this video tutorials for you, and by clicking like, subscribe, and share this video with your friend. Okay, I will see you in the next video. Assalamualaikum warahmatullahi